Hi, Alasdair.
Hey, Dale.
How are you doing?
Not so bad.
So you're visiting today, and we've got a table setting here with some wonderful Arduino delights, I guess. But your specialty really has been working in the sort of the connecting the iPhone and the Arduino together.
Yeah, I mean, what I'm really interested in is the trying to get the sensors and distributed sensor networks and all that sort of stuff hooked up into the mobile space.
Right. Just so folks, give us a little bit of background on what you do.
So actually, my day job is astrophysics. I work in the astrophysics department at the University of Exeter, and I've sort of ended up playing with the toys rather than doing the science. Mm-hmm. So I've sort of sidestepped into doing computer science while embedded inside a physics department. Mm-hmm. I do one of the things I do for the day job is autonomous telescope networks. And if you think about it, telescopes are just really big sensors that happen to be pointed upwards. So as a part of that, I've sort of slipped into doing mobile development because it's really good. They're good devices to act as hubs for these sensor networks that I'm developing, which has sort of led me into the whole O'Reilly sphere and writing books for you guys. Mm-hmm.
When did you first hear of Arduino and the connection of what you're doing?
So the Arduino stuff, it just sort of started turning up in the web, and it was just like, oh, that just solves so many problems. Mm-hmm. It was it's basically, it turns hardware problems into really easy software problems. And while I am a physicist and I do have the theoretical training to do a whole bunch of electronics, I can't remember any of that stuff. Mm-hmm. I'm mostly these days a software guy. Mm-hmm. And just to have the power on the Arduino to turn what used to be really hard to do. I mean, turning an LED on and off from a microcontroller used to take you a couple of days' work if you were going from ground zero. Mm-hmm. And now with an Arduino, you can do it in a couple of minutes, and that's a really powerful lever to give to people. Mm-hmm.
So you wrote this book, iOS Sensor Apps with Arduino.
Yep.
And that actually came out of a hardware hacking class with iPhone that you were teaching, right?
Yeah. So the book was actually intended to be. It's a modestly interesting story. The book was actually intended to be something totally different. Brian Jeffson and I, Brian's my editor, we're discussing doing a book about how to connect the iPhone to the real world. Mm-hmm. So I'd been doing stuff with, the Square thing, the credit card swipe. Yeah. So they actually use the headphone jack on the iPhone. And we're both old enough to remember acoustic coupler modems, right? So my first modem was two rubber suction cups with the telephone handset. That you can't even forget those telephone handsets anymore, right? But so they're doing the exact same thing. They're taking digital information, they're transferring it into an analog wave, and they're pushing it down the headphone jack, which is a really cool hack, but it's really slow. And I was actually doing stuff with this, and we're looking into other ways to do it. So that there's dongles that do the ANT Plus protocol, for instance, and also the iPad does MIDI, and where I was experimenting with tunneling arbitrary serial over the MIDI protocol. So the book was all going to be about this sort of stuff, and then just as we were thinking about, I was sitting down to write the book. A company called Red Park came and talked to me. I'd actually been talking to these guys for a while, and I had a developer cable from them, which looked a lot like this, which was Apple 30-pin dock connected to RS-232 serial. This is the connector that will never die. We will eventually plug starships together with this because you can't kill it. And Apple had suddenly decided that they were going to authorize them to put out a hobbyist cable. Mm-hmm. And it was such a big thing because to build accessories for an iPhone, you need to be part of something called the Made for iPod Works with iPhone program. It's this developer program for hardware manufacturers. Mm-hmm. And it's
a little costly?
It's a little costly, and there's a little bit of lawyering involved.
Yeah. So not the average maker's going to walk in there.
No, I mean it's not even the average small medium enterprise who's going to make in there. It's unless you have existing relationship with Apple or you have a bunch of money and a bunch of lawyers. It's a hard program to get into. Mm-hmm. And then suddenly this really opened up the space. So I actually sat down and wrote the book in 2 weeks because it was just so. Literally the 2 weeks was I didn't sleep for 2 weeks. Mm-hmm. But it was such an interesting thing, and it was just suddenly they were opening up a whole bunch of possibilities that. Because
let's look at one of them here.
Sure.
Yeah, let's see what you.
So this is like the absolute simplest thing you can do, which is pushing a button. So let's just turn the Arduino on and off. And you push the button, and the LED lights up. And I can actually sit here and do this all day because it's just such
addicting.
Yeah, it's such a cool thing. So you can see here, so this is Apple 30-pin dot connector, the standard dot connector. In here, there's a bunch of crypto chips. They're authenticating this as an officially approved device to the iPhone, which means that this is not a jailbroken iPhone. This is like a straight, normal iPhone that using Apple's own SDK. So it goes to RS-232 connector there, and this is just a RS-232 to TTL level shifter. So it's like a $7 part off the maker shed or something. Because of course we're using Arduinos because Arduinos are cool, but Arduinos talk TTL serial. So on the Arduino, there's actually, I think there might be as many as 10 lines of code, and all it's doing is just sitting there looking for a byte to be sent down the serial cable. And if there's a byte, it toggles the pin 13 high or low, depending which state it's currently in. On the iOS side, this
is kind of a hello world.
This is literally the hello world of
an integrated
of anything, really. And on the iOS side, it's almost as trivial. So the cable comes with its own SDK, which sits on top of Apple's own external accessory framework. But the SDK makes things really trivial. There's a method to write bytes down the cable, and then there's a delegate callback. So basically, your application will be notified when bytes turn up from the cable, and it's really as simple as that. So if you've ever done any serial at all, it's really trivial. So at the iOS level, it's a pretty simple thing to do. But so that's Hello World.
Very good. So Alasdair, we have a new cable that sort of eliminates this serial cable.
We do. I mean, where we had a RS-232 cable here, which is really cool for some things like lab equipment and machine tools, all have RS-232 equipment interfaces. In the hobbyist market, in the makersphere, we're far more interested in TTL serial because that's what Arduino uses. That's what we're used to. So the RedPart guys are actually coming out in the next couple of weeks with iOS dot connector to TTL serial, and you can see this is just a standard FTDI cable here, and we've got it hooked up. And as you can see, we can actually control some flashing LEDs.
Great.
So that's quite cool.
And you're just hitting it on there, turning them on and off.
Yeah. So this is just what I've actually got here is a bunch of switches connected up to the Arduino pins. So what's actually going down the cable every time I hit a switch is 2 bytes. The pin number and a 1 or a 0 to tell the Arduino to send the pin high or low. And on the Arduino end, there's literally 20 or 30 lines of code in there that's just looking for those 2 bytes coming down the cable. So what you're doing here is you're actually moving the smartness of some of the Arduino sketches that you might want to do off the Arduino and onto the iPad, where there's a lot more processing power.
Right. Now, what happens if you disconnect right now?
Well, you can see that the cable's disconnected at this end,
right,
but the Arduino is still doing what it was doing. Because
so you set those lights?
I've set those lights on and then disconnected the cable.
Right.
So if you imagine that's a whole home automation system, that could be the temperature of your aircon or anything like that, right?
And the point you made earlier was that you're doing something in software that's much easier than you would have been able to do it 10 years ago.
Sure, absolutely. And the thing that's interesting me about this setup is that you're actually doing something in software on the iOS end that's actually easier to do at the iOS end than it is to do on the Arduino board, where there's much more limited memory and processing power. So one of the cool things you could do with this is you could use the Arduino to do the motors and actuators of a robot, for instance, and then you could use the iPhone as the brains. So you could just simply have the dot connector sticking up in your robot. You could plug the iPhone directly into it, and the iPhone's got a camera right there.
Right. I mean, it's not different in a way that sort of a lot of our computers have different processors to do different things in there. So you already sort of have sort of roles and responsibilities in like a computing platform, and that's what you're talking about, like a robotics platform. You've got to figure out, how to break things down so they're not all competing for the same, time and attention of a processor.
Absolutely. And the cool thing is that you can now, with this sort of technology, you can actually just use the appropriate processor for the appropriate job, right? You don't have to try and cram things into the Arduino board, which is really cool at talking to hardware. But you don't want to try and run OpenCV on an Arduino board and try and do facial recognition or any of the fancy stuff that you can do on the iOS devices or the Android devices.
And some of it, again, it's what we've got here and what we can't. We have a pack of sensors there. We can have more specialized sensors here. You have a little bit. You can't interchange a new sensor on the iPhone.
Yes.
You're stuck with what that has.
So
but you could add it onto the Arduino board.
So things like this cable and the things like Bluetooth 4.0 and Bluetooth Low Energy, which is coming up on the new devices, are really going to let you sort of open up the accessory space for the mobile phones, I think. And I think that's actually going to be a real opportunity for hobbyists, for makers, to do some really cool stuff.
What does this Bluetooth 4.0 give us that?
Right, so Bluetooth 4.0 is the new generation of Bluetooth standards. It's the Bluetooth you're used to, where you have to pair devices between themselves, is Bluetooth 2.1. Bluetooth 4.0 is a much more low energy thing. It's designed for embedded hardware. It's designed for sensors. It's designed for distributed sensor networks. It does away with pairing, for instance. It moves to a more bonjour model, where they advertise services. And the interesting thing, from my point of view, for iPhone development, is that the iPhone 4S and the new iPad comes with Bluetooth 4.0, as well as the MacBook Air, for instance. And interestingly, this AMFI program I was talking about, Bluetooth 4.0 isn't in it. So Bluetooth 2.1, the previous generation, was if you wanted to build a Bluetooth accessory for your iPhone, you had to be part of the MFI program.
Right.
Well, now with Bluetooth 4.0, you do not.
There's something new coming for Arduino in
There's something new coming for Arduino in that space. So the Redpart guys, the guys that do these cables, they're actually putting together a Bluetooth shield for Arduino. It's going to be a Bluetooth 4.0 shield that's going to talk RF comms, so the serial stack for Bluetooth, directly to the iPhone. And there's a few Android devices now that are also supporting Bluetooth 4.0. Right. And the cool thing on the Android side, of course, is processing for Android. So you can build your Android app with processing, talk to the Bluetooth stack, and on the Arduino side, you can use the Arduino IDE to build up your application there. So suddenly you've got access to remote sensing platforms, to distributed sensor networks directly from your phone or your tablet.
Yeah,
I think that's going to be really powerful. I mean, certainly, I think it's going to change. XB is usually used for this sort of distributed sensing in low power environment, and I think Bluetooth 4.0 might displace that, because you're not going to get an XB or 802.15.4, which is the protocol name, on these sort of devices anytime soon. But Bluetooth 4e is coming, and when it comes to the Arduino side, suddenly you can build up a network of devices, of sensors, really easily at that point.
And so that's opening up some really new opportunities.
It is.
New ways we may have thought about it, but we didn't clear how to do this.
The Arduino platform for me is really is a prototyping platform, and it's really cool for prototyping stuff. But the thing about it is that you can take this big chip, and you can get the surface mount version, and you can blow the Arduino operating system and your sketch directly onto that, and you can shrink that down into something that's much, much smaller, production level stuff. So you can go from this prototyping platform to a production level thing really easily. And certainly when you're starting to talk to these sort of devices, and you can prototype your stuff on this, you can go really cheaply from a small prototype to a large run. I mean, that's what Kickstarter's there for, right?
Right.
To go to a production level device.
Right. And is it sort of that this sort of becomes a semi-intelligent sensor, in a sense that's really cheap. You can deploy them, and then devices like iPhone or iPad are how you aggregate them and
absolutely.
Talk to them
I mean, we talked about my background earlier in the conversation, right? And my background is distributed sensor networks, and you can basically get sort of things called sensor modes, right? Which are like a board, and it's like some sort of wireless on board, a bunch of sensors. And the military have been using these for a while, and you basically get your squaddies, we call them in the UK. I mean, I think grunts is the US term.
Yes.
Yeah. Okay. So you get your grunts. They've got a big backpack of these, and you distribute them over the battlefield or the area of interest, and you can actually synthesize a lot of situational awareness out of these, for the military, fairly cheap sensor platforms. But for the military, fairly cheap, we're talking about $1,000 a sensor mode, right? Well, suddenly Arduino boards, or even if you don't use the board, if you just use the surface mount chip, you're talking $10 for that. The sensors are like $20 there, $10 there. Suddenly you're looking like less than $50 for a sensor mode.
Yeah. So considerable improvement there.
Considerable improvement. You're moving
which
out.
Means that particularly for commercial applications, farming, or something.
Oh yeah,
right?
farming, absolutely. It's like it's going to be. We're on the cusp here of really tipping point of moving from where this stuff was hard to where this stuff was easy, and sort of the ubiquity of these sort of devices, the fact that you can connect these suddenly connect these devices, which are you can't go out and build this yourself, right? You have to be somewhere the size of Apple or Google to build these. Right. But these are far more accessible. So the whole maker thing, if you can't open it, you don't own it. Well, I always think that there's a little space for things like this, right? Because you can't build these on the maker level scale. But if you can make these talk to these, suddenly you the big corporations have given you a lever to do things you can't do.
Yeah, and in a sense, they've brought that processing power into a package that makes it really, it's portable. It's like you said, earlier you probably had more processing in your in there than you did for your PhD.
Yeah, absolutely. There's more CPU in this than the machine I did my PhD on.
Yeah.
And that's just astounding to me.
So if I'm a maker and I sort of get this idea of ubiquitous computing and start thinking about what this is, and maybe I know a little bit of Arduino, but I really don't know the iOS side of things.
Yeah.
Where do I start? I guess sort of how do I start exploring this? How do I move this forward? This is kind of simple sketches.
Yep.
I can sort of connect things, but now I'm connecting to here, and I've got to go into a different environment now and start thinking about how these work together.
So it's actually not that hard. I mean, if you're an experienced Arduino guy, if you've done some C, or you've done some Python, or you've done processing, it's just moving the brackets and the semicolons in a different place, right? It's like when you know a couple of computing languages, like one more is not that hard. So on Android, it's Java, and on iOS, it's Objective-C. And this is my book. Well, I have another book, which is Learning iOS Programming, which it takes you all the way through from installing the Apple Xcode environment to getting to the point where you can put an app onto the store. And so it's about 300-page book, so it's not that long. There's not that much to it. There's a lot of fiddly stuff to do with digital rights management and certificates and all that sort of stuff. But I walk you through that. Yeah. So it's if you have some programming experience, these platforms, they're not actually as challenging as they look. It's like the environments to program these are really, they're advanced, but they're advanced in a way which tries to make things easy for you.
Well, let me flip the question and say, if you're someone that's doing, your life has been mobile apps.
So if your life
apps,
if your life is on the other side, if you're a professional programmer, you build apps, you write big, you write parts of the Linux kernel or whatever. It's like if you're a heavy duty programmer, this stuff is trivial. It's like the hardware stuff. There's tutorials on the web.
By trivial, you don't mean without value.
No, I do not mean no. I mean it in the mathematical sense. It's like there's a joke amongst mathematicians. You'll hear them talking to each other in the hallway for hours, like doing the most weird, obscure stuff, and then one goes, "Oh, it's trivial," and they go, "Yes, it's trivial," which means for mathematicians that it's solvable.
Yes.
So yeah, sorry, I was using the word in the technical sense. Yeah,
yeah,
absolutely. So it really is easy. So the hardware is so as I said, I'm a physicist by background, but I can't really remember how to do electronics properly, right? And this is why I love the Arduino platform, because I don't really have to remember how to do electronics properly. I can bootstrap myself into it again, because it solves a lot of the problems you used to do in hardware with just some simple software and the microprocessor. And that's a really cool thing to do. So, if you can do this, you can really easily do this. And this is the book for hardware hackers. This is the book for iOS developers, hardware hacking for iOS developers, basically. Right. So if you're on this side and you want to learn how to do this, you can just buy this book.
So connecting the iPhone and iPad to an Arduino, looking at what we can do, this sort of connection between hardware and software, a dialogue.
Yes.
Where there are different roles for different devices. Thank you a lot for sharing this, and I look forward to your video, which you're working on here, based on the book. I think a lot of makers could be real interested in learning how to do this. They either know this, and there are going to be iOS developers who want to know what makers know about Arduino.
Yeah, I mean, I think it's going to give a big lever to both communities. It's like the maker guys suddenly have a great platform to do display and processing and analysis on, and the iOS guys suddenly have access to a whole world of sensors and actuators that they can use.
Thank you very much.
Thank you.